So my name is Erik Bonost. I am running the performance engineering team at NVIDIA. I used to be a grid solution architect at NVIDIA in Germany, and before that I was working at HP on remote desktop solutions. With me I have Emily.
Hi there.
I think most of you know Emily. And so this presentation is about benchmarking grid, and specifically about the VPC market, so that's our software edition regarding the knowledge worker workload, and the designer market, so our Quadro virtual data center workstation market. That's the new branding or the new naming that Jared announced yesterday. Yeah, I'm also a member of Team RG. I think a couple, at least Thomas I've seen, is a Team RG member as well. So yeah, that's it. If you have any questions, comments during the presentation, right, feel absolutely free to interrupt me. I will try to answer them, even if it's maybe a little bit off topic. So I chose these topics for this audience, but if there's something else you want to bring up, let me know. Okay, so one marketing slide, and I'll stop after that. At VMworld this year, we did we called it a user experience challenge on the booth floor. So what we had is, we had a rack, we had two identical systems. One system was powered by GPUs and one other wasn't. And we had a lot of VMs running on them. And then we had stations where users were actually doing exactly the same test and were rating the user experience. The tests that they were doing were WebGL1, Google Earth, and watching a YouTube video. And the users actually on the show floor, so just normal VMworld attendees, 99% rated the user experience on the GPU-enabled VMs as, great, I can work with it, I would like to work with it. And only 9% rated the user experience as, hey, cool, I can work with this, I like it. In addition to the difference that GPU make in terms of user experience for this knowledge worker type workload, the GPU-enabled host had 30% more VMs running on them. So it kind of, if you know the marketing claims that NVIDIA is making, once you add a GPU to your system for the knowledge worker workload, you're not only gaining better user experience, but you will be able to run a little bit more VMs as well. So this is what we did at VMworld. When we started to, and this is now becomes more, I'm moving now from the marketing side to the more technical piece. Quantifying user experience, first of all, user experience is very subjective, and for NVIDIA it has been challenging to define the differences between GPU and non-GPU enabled virtual machines. So at some point we kind of got lost a little bit in what is available in the marketplace, not necessarily providing what we see in the market and the demand that we are seeing in the market. So we decided to do it ourselves, and we built a tool which we call Project Cirrus. Cirrus is our benchmarking tool that not only does the automation piece of things, but it measures the things that have not been measured before. So we looked at how our other business units within NVIDIA define user experience. So we look at, and we're basically taking technologies, methodologies that they use in the GeForce world, in the gaming world, in our cards that are being used just for having multiple screens at high resolutions, etc. And we're applying them now to the grid world, to the virtual world. So what we've done is we measure things like end user latency. And what I mean by end user latency is it is the overall latency an end user will perceive. So basically, how interactive is your session? So moving your mouse, how much lag? How much is it like local, It includes network latency, but it also includes the latency of your USB stack, Rendering on the remote side, displaying on the client side, etc., The encoding process, everything. So it gives you an idea of how laggy or how snappy your user experience is. We look at how many frames are being rendered and how many frames are actually being delivered to the end user, Number of frames is a good way of quantifying, or is a piece of quantifying user experience. We look at the consistency of end user experience, Are all your VMs or all your users on your host getting a stable user experience, or is it floating, right? Sometimes good, sometimes bad, right? Based on maybe on resource contention. We have developed a tool that allows us to measure image quality. So we are able to quantify the image quality. So basically we are comparing a frame that is being rendered on your remote desktop, and we're comparing that to the frame that is actually being delivered to the end user, and we do an image comparison, right, to quantify how much effect the remoting protocol has to the end user experience. By having all these, right, measurements, right, I'm not saying it's a perfect way, but I think it's a very good way of defining something that is subjective and trying to quantify user experience, right? How interactive does it feel? How many frames are you being generated? So how fluid does it look like? And the consistency plus image quality. In addition, we look at the resource consumption, right, of what is happening inside of the virtual machine, but we're also looking at what is happening on the host itself in order to find out, right, how much further can you scale before end user experience degrades, right? So this is what this tool does, and we use that to output realistic sizing recommendations, right? As you can expect, right, we have developed, or we had to develop benchmarks for this. So we have developed our own knowledge worker benchmark that allows us, right, that takes into account the usual suspects of applications, right? Chrome, it plays videos through YouTube and locally. It's Word, Excel, it's PDF, and we try, right, like everybody else, we try to make it as realistic as possible, right? But we also do scrolling, and we have the addition, right, to do multi-monitor testing and different screen resolution testing, as an example. So it has a UI. At the moment, it's an internal tool only. If you have a customer where you think this tool is of interest, let us know. We'll try to work with you. But the tool has some limitations as of now, and we'll get to that. I'm telling you about this tool, even though it's an internal tool, right? Because we do want to work, and right, if there is need, right, to use this tool, we want to know. But we also, I kind of need to share it because I want to make sure that you understand, right, the metrics that we're using to quantify and to define the difference that GPUs make. This tool allows us basically through the UI to set many, many different things. As you can see on the things that are mentioned here, it's basically VMware settings at the moment. We're working on integrating Citrix, and we're almost there. But within the UI or the config file, right, you can specify which host you want to target to do your benchmarking on, right? How many vCPUs your VMs should have, how much VRAM, which NVIDIA Grid VGPU profile should have, which data stores should be used, the screen resolutions, the number of screens, which isn't mentioned here, and we have different workloads. We have workloads, knowledge worker workload, we have workloads that work for the designer workspace, so basically spec UPerf. You quantify how many VMs you want to test. You set the very specific NVIDIA settings, frame rate limiter, right? Are you going to stop frames being rendered? More of a something that is interesting to the designer workspace. Allocation policy, VGPU profile, and the scheduling policy. You can choose which remote protocol you want to be testing, and these are the metrics that we're gathering from the different sources, right? We gather metrics from the end user, gather metrics from the desktop where the actual workload is running, and we're gathering metrics from the host where the VM is actually running on. Right, and Citrix and desktop is developed. So the cool thing about this tool is, right, and why we're able now to generate much more meaningful data than we have ever been, is you fill it out, you press a button, and that thing, based on master images that are pre-configured, it will do everything. It will provision the VMs, it will wait until all the VMs are provisioned. It initiates the remote desktop connections, it runs the workload, it gathers the data, it analyzes the data, and you get a report. So how the workflow works is, so this is actually not my slide, so I'm trying to make sure that I get it right. Well, then I'll just explain it from my view. Don't look at the slide. So what we do is, right, once you kick off that script, what happens is we speak to the vCenter APIs as an example. We provision all the virtual machines. We set everything that is specific to the virtual machine, right? vCPUs, GPU settings, etc. Everything that is required. Once we have, let's say, 64 VMs provisioned, We also require a second host where our virtual clients sit, right? All the VMs will be provisioned there as well. Once all the VMs are provisioned, we establish a remote connection between the actual clients, right, and the desktops, right, or the actual workload VMs that are running the workload. Once everybody has a desktop connection established based on the remote protocol and the settings of the remote protocol that you have specified in your config file, we make sure that everybody is ready, right? Everybody has synced. We start the monitoring, right? We start the monitoring on the client, on the desktop, right? So by client I mean, sorry, the access device, the thin client, right? Which in our case is a virtual machine. We start the monitoring on the desktop that is actually running the workload, and we start the monitoring in the hypervisor that is actually running the workload, right? Or where the VMs sit that run the workload. Once everybody has started monitoring, that's when we kick off the workload, right? We have the possibility, right, to do like a staggered start, so, right, I don't know, whatever you set, right? Every 20 seconds a new VM starts running, or you do it, right, synchronously, whatever you want to do. And you specify how often you run the test, right? You typically want to run, I guess, 3 times just to make sure that you don't have any outliers and the data is consistent. So it runs 1 iteration, right? Let's say you run with 64 VMs. 64 VMs have finished the workload. They stop. We gather the data and we kick it off again. Second iteration is finished. We gather the data. You stop. Third iteration, right? Everybody runs. We gather the data. And when all 3 iterations are finished, we then start to analyze the data and we create a report. So it's an easy way, right, for us to do benchmarking at scale with multiple iterations to make sure that we have consistent data. So it takes care of everything, at least everything that we can think of right now. Let's pull it out.
Overall, there's about 5 CSVs, one holding, do you go into that?
I don't think, but that's a good point,
Okay.
yeah.
Mm-hmm. So there's one CSV that's VM configuration, a CSV for server configuration, a CSV for stack configuration, and then the benchmark metrics. So there's a lot of CSVs that we analyze. Right now we're producing a database report for internal, but we also create a PDF report for quick analysis.
So the other important point, and good that you're speaking of it, is we often get questions by the field, right? We ran this benchmark, whatever benchmark it may be, and then we have no idea what the benchmark was run on, right? We don't know the server details, we don't know what the settings in the BIOS were, and we have to ask all that questions. What we do is we go to the APIs of the vSphere or vCenter, and we read everything out. So our report will include, you ran on a, I don't know, HPE DL380, right? The BIOS setting were maximum performance, and right, you had this version of the BIOS on it, you had you set multi-threading enabled, all that stuff is being, right, we read that out. So we get a report and we actually, right, we are able to understand what the report was about. Any questions so far? Okay, so at this point, right, you understand how we do the benchmarking. I'm just going to go into the end user latency part because it's one of the metrics why people buy GPUs for the knowledge worker piece. So, what end user latency is, we used to call it click to photon. I don't know if anybody has seen data that we generated. Click to photon was, we had an oscilloscope, so it was very, right, a physical solution, modified mouse, an oscilloscope and a photodiode on the screen, and we measured the time from the click to when the screen reacted, and, right, so basically a round trip latency. I'll cover that in more detail. So what end user latency does, we initiate a mouse click on the access device, right? So we do this now through software in Cirrus. It clicks, right? And this click is then going through the client or the thin client, the access device. It's being processed through the USB stack, sent over to the actual VM, right, that is running the workload. It triggers something on the VM, in our case a PowerPoint presentation, a slide, so it changes the slide. The slide on this guy changes, right, on the VM. And the slide, right, then the remoting protocol picks up the new frame and sends it back to the end user so that the end user can actually see the new slide. We do a timer, right, we measure the time, right, when we do the click and when we can actually see the new frame being generated. So it explains how interactive your session is, right, how laggy it is. So that's one of the metrics why people buy GPU and something that we are measuring, and it's, we believe, and that's coming from, right, from our business unit, that's essential to defining end user experience. So just to share some data, and as you've seen, our tool only works with VMware at the moment, so we kind of used a VMware solution in this case. I understand that a lot of audience is more Citrix focused, but nevertheless, that's what we've tested with and the data that we want to share, right? So it's a typical DL380 with I think a quite typical CPU that you would use for a knowledge worker workload, right? This one has a lot of memory, right? But we don't leverage it. It has 2 Tesla M10 boards inside of it, right? These are the settings that we've used. This is the VM configuration that we used. There is, I don't think anything very specific about this, right? Well, you can choose it, right? Or you probably would choose a different NIC. But that's pretty much it, right? Okay, so that's the system that we've tested. And just to be aware, right? When you choose VMware Blast, right? And Blast is a protocol, and we use the HD64, right? There are 2 pieces where the GPU now accelerates. The GPU has dedicated engines on the GPU that are there to do H.264 encoding and decoding, right? So if you add a GPU and you use a remote protocol that leverages our H.264 encoder and decoder, right? Blast is one, Nice DCV is one, HPRGS is one, HDX 3D Pro is one, right? If you choose the right setting, then we will not only, right, give you the advantages of having a GPU, but also the advantage of offloading the encode process to our dedicated H.264 engines, right? So we are offloading the CPU at that point. So 2 pieces where we accelerate. What it comes down to is, so this is I believe a 64 VM test on that server, and the end user latency is, right? So again, it's not network latency, right? It's end user latencies. For the NVIDIA Grid acceleration, and at least the quality seems very bad when I look at it. Is it bad for you as well? Yeah? Okay.
Which operating system was it?
Windows 10.
Okay.
Yeah, sorry. Right, the end user latency across the 64 VMs was around about 140 milliseconds, right? That includes, and that is measured at a network latency of below 1 millisecond, so LAN-based, right? So there are 140 milliseconds or everything that I just explained, right? Clicking, right, going through the OS, right? At the end of the TCP package has to be, right? Has to be, or UDP package has to be extracted, and the rendering has to happen, and the frame has to be grabbed and being encoded and being sent back to the user, and it has to be displayed there. If you have a CPU-only VM, right? You don't have a GPU, your end user latency is around about 350. So your users will see, right, a much more snappy user experience, right? It feels much more local. And if you look at the consistency of end user latency, right? How consistent is it across users, right? You will see that the end user latency of NVIDIA Grid is more consistent than it is if you don't have a NVIDIA Grid solution in there.
But have you actually tested this on local as well? So people come to an office and they expect the same speed they have with their own laptop. And that's the same thing you're trying to do, make everything more snappy.
Yeah.
But have you done the same type of test on those actual laptops?
Yeah. So on it, so there's no way, right, in terms of end user latency, there's no way you're going to get to the end user latency of a local laptop, right? Because there's a network in between. So the numbers for a local laptop will be around about 60 to 80, 85 milliseconds. So, right, so you are, right, you're getting closer, right? You can't achieve it, impossible. But you're much, much closer than without having a GPU, right? So it's a fair comparison. That's ultimately what we're going to do, right? We always used to state, and when I was in SA, right, the idea was we want to be as good as local, right, or better. That's kind of what we need to achieve. It's impossible in terms of this metrics, but, right, we try to get as good as possible.
But it depends on the machine. Because I've seen with very big GPUs, you can actually reduce the latency time with mouse extremely, even faster than very fast machines that are locally.
That's impossible. If you were to,
I have seen it, so
it's impossible. It's physically impossible. If you were to choose the same, have the same operating system, the same GPU in a local machine, you should have.
But there's a logic behind it because the GPU is smaller in the physical.
Yo,
No,
yeah,
that's-
then
No,
it's-
no, but that's why I'm saying.
Yeah, but then it's not an apples to apples comparison
Yeah.
anymore. But then, yeah, then it can be. You're right, possibly. But even, I mean, it's questionable. But it's right if you don't have the same hardware, yes, possibly. Okay. Second piece, remoted frames, right? Frames, right? You will only have a good user experience if you have enough frames, right? The remoting protocol, or most customers wouldn't set the remoting protocol to deliver more than 30 frames per second for these types of use cases. So we looked at, right, what are the remoted frames that you get with a GPU-enabled system and with a CPU-only system, and we're delivering around 3 times as much frames, right, for the same workload, and you're bound at 30 frames per second by the remoting protocol. So, not a surprise that GPUs help you with number of frames, but it's quite significant, right? And again, these were the standard applications, right, that most of us use. Image quality. So what we do is we have our agent or our script that does the piece of end user latency on the client, so on the access device. It also looks at the frames that are being generated or being sent over the network. And after the actual test, because it's a very high required processing, it's a process that requires a lot of resources, we do image comparisons. We use a tool or a way of measuring it, which is called SSIM. It's a good way of measuring image quality for mainly static images, not necessarily for moving images, but it's the best way that we could come up with. And it compares, right? We have the frame that is being rendered on the VM, and we have the frame that is rendered or delivered to the end user, and we do a comparison, and we see that, right, there's a difference in terms of image quality. So 1 is a perfect image, and the closer you get to 1, the better the image quality is. Both might be good enough though, right? I'm not saying that this one is a terrible image quality. This one might be is better, but that might be good enough in that case. Even though it's H.264, right? In this case, VMware must have chosen a little bit of different settings when GPUs are available, because that would only explain why there's an image quality difference. So everything that I've spoken to about was about user experience, right? What the end user will feel, and we believe that you can only make sizing recommendations if you take into account what the user experience is that your end users will have. Once the end users are getting a user experience that isn't good enough, right, then you should stop scaling. So what we've done is we looked at the CPU utilization during that run, and a GPU will only help you when you're actually running workload, right? So if I had 64 VMs and they were basically doing nothing the entire time, right, there's nothing that we can accelerate, right? GPUs are accelerators. So we look at the time when the VMs are actually running, right? Because that's what we care about, right? We want to say size based on when there's actual workload. So what we're seeing is, depending on what is currently happening, right? There might be, right? It might actually be that the GPU system requires a little bit more CPU resources, but there are, in general, there's time, right? Usually we save a lot of CPU cycles, right? This is kind of the marketing claim, up to 28%, so this must be probably somewhere here. But in general, right, we do save CPU cycles, right? And it's around about 15%, I think is what is a fair comparison to say. But again, we save, right? Normally, right, we deliver so much more user experience, and we're not delivering the better user experience at the cost of CPU cycles, right? So we're delivering much better user experience, and we are also reducing CPU cycles that are required to actually allow you to scale higher. We also looked at, we took out, right, we kind of separated our workload into different applications, so it's built very modular, and we kind of looked at where the benefits really are. And so example, right, Chrome video, green is NVIDIA, right? You see the CPU utilization for videos is very significant, right, the difference. Chrome, right, you see these spikes, they don't go as high on GPU. There's a lot of scrolling happening in this case. We have a couple web pages. that we run on our web server, so we don't require actually any internet connection. Microsoft Edge, right? You see quite some difference here in terms of CPU utilization as well. PowerPoint, quite significant as well. Excel, actually not that much, right? Maybe even in average nothing. Right? It just depends on what you're doing. But overall, right, we've seen there's CPU offload. Okay. So for the knowledge worker workload, right, the VPC market, we have a specific board that NVIDIA has built for this use case. It's the Tesla M10. Everybody knows the Tesla M10? No? Okay. If not, I'm just going to... So the Tesla M10 is a board that is designed for this workload, right? Normally we try, the knowledge worker workload is not necessarily a workload that is a GPU-bound workload, right? Everybody wants GPU, but they don't require high amounts of GPU. So the idea is really to just have a lot of scale, give everybody a little bit of GPU resources. Tesla M10 is great because it's actually a board, right? It requires, so it's double width, so it kind of goes over 2 PCIe slots, but it has 4 individual GPUs on the board. Each GPU has 8 gigabytes of memory, so in total, frame buffer, so we have 32 gigabytes of frame buffer. So it allows you to scale up to 64 VMs if you were to choose a VGPU profile that has 512 megabytes. For Windows 10 though, the best practice is to use the 1 gigabyte profile. So 32 users on an M10, and there's I think one server vendor that supports 3 M10s in a server, so you can go up to 96 users and for that particular. But we believe that the ideal number is round about something between 60 and 80, and that's what we're getting the feedback from other customers. Can I just do a quick test, because I know product management is very interested in this. So I know it's a little bit of an unqualified question, but I'm sorry to ask it, but product management really wants to know this. Has anybody had a VDI, not RDSH, a VDI environment where they can host, where they actually have 100, let's say 150 users on it? Windows 10. So sorry, let's start first. Windows 10. Who has customers that run Windows 10? A lot, okay. 150 users, Windows 10, active? 1? Okay, I'd be very interested to hear more about it. 140, 130, 120, 110, 110, 100.
So.
100? Okay, 90, 90, 80, 70, 60, okay, 50.
Where are you?
Yeah, where's everybody? 40? Okay, more. 30. Okay, more. Okay, I'll stop here. Okay, it's interesting to hear because there are so many marketing claims, right, that speak about, right, 100 and more.
Define the term what you're just asking about.
I was asking about if anybody has a customer that is running more than whatever the number that of VMs that I was just asking of Windows 10 users on his server.
Yeah. So what I'm
Yeah, but you're talking about multiple. But are you talking about multiple GPUs in one host?
No, just one host, independent of it's a GPU or non-GPU.
So did you?
Okay, but then
how many
okay.
cards did you run?
Sorry?
How many cards did you run with more than these 100 users?
I have to check with them. I don't know.
I have one where it's much more than 150.
And it's VDI?
Yeah, they it's a lot.
Okay,
Per host?
so sorry for
Yeah.
this
Which card they use?
They don't
Which
use
profile?
GPU. They don't
Okay.
use GPU. It's
Okay, we'll take that offline. I just wanted to know. So,
a very high number.
so the M10, getting back to the presentation. Thanks for the feedback though. For the M10, right? We believe that from what we hear from our NGCAs, right, that is kind of our CTP program, and what we're seeing in the field is that most customers for Windows 10 are somewhere between 40 and 75, 80 user. That's what we see in the field. Our NVIDIA VDI implementation is actually 23, just to give you an idea. And it's users like I don't do anything very specific graphically. So the M10 is great because if you put on an M10 with a 1 gigabyte profile, which is the recommended profile for Windows 10 users, the rendering engine, the GPU, right? You can see you're using the GPU, but you have headroom, right? In case your workload is different to ours, which of course it will be, right? It's a proxy, it's synthetic at this kind. But you have the possibility to spread out. So the GPU on the M10 seems to be working very well for 8 users, and again, there are 4 GPUs on an M10, and you can put multiple M10s into a system. The encoder itself, right, so the thing that does the H.264 offloading, right, for 8 users on the encoder, again, right, you're using it, but you have a lot of headroom in case you're using multiple screens, higher resolutions than what we've tested with, right? So again, the encoder is sufficient for your knowledge worker use case.
Sorry, not
Yeah.
to interrupt. Just to make sure that it's clear, they're using depth first, so all these VMs are on one single GPU.
Correct.
It's not across
Yeah.
the GPUs on the card.
So frame buffer, right? The frame buffer utilization, and why I'm saying that 1 gigabyte is the recommended profile for Windows 10 users, right? 512, by the way, works great with Windows 7, is that you can see that we assigned a 1 gigabyte profile to the actual VM, and you can see that we're above 50% of the frame buffer for most of the time. So 1 gigabyte is a great VGPU profile to choose. So just kind of putting that back together, M10 is great because it's the GPU that has the most frame buffer that you can, or the board that has the most frame buffer that you can put out there. Therefore allows the best scalability, having, right, and matching the requirements of the VPC worker.
So you're saying it's best practice to use 1 gigabyte in Windows 10?
Yes.
But it really depends on the company, what they do. Because what I see is, if they somehow opening up 20 to 50 tabs, and they have extremely a lot of content just in the browser, right? The frame buffer just...
Yeah.
That's why I said,
It's right.
Gigabyte.
like,
I mean,
And it really depends on the use
Right.
case. So if you have your normal office use case at a Windows 10, so 1 gigabyte profile might fit.
but I'm seeing some customers where they do 1 gigabyte, but then after 3 months, they like...
so that what
That
I
might happen.
and that's why I said, right? I mean, we all know it depends always, right? I said based on our proxy workload and synthetic, and yours might be different, right? But for a general user where this application or this workload kind of fits, that's where that, right? If you have an extreme use case where there are 50 tabs open and over time it gets more, sure, right? Assign a different GPU profile, but your scale goes down, right? But they're also more, they require other resources more as well at that point, right? Okay, so just for the knowledge worker, right, type of solution, right? The benefit of having GPU is this, right? We reduce the CPU load, we increase the user experience significantly, and the M10 is just a great board because it fits the needs of a knowledge worker workload at scale, right?
I have one more question. Have you guys been testing it between 2 vCPUs and then 4 and 6, and plus have you tested between, now I saw you said 4 gigabyte memory, but have you also tested up? Because I know there's a big difference in if you change the numbers.
So we tested, and in terms of scale, we saw the best for 2 vCPUs and 4 gigabytes of RAM was enough. But again,
Okay.
right, workload.
For Windows 10?
Yeah.
But if you go back some slides, you can see that this host has only 2.3 gigahertz of RAM. That's not that common for GPU virtualization environments.
Okay,
So
yeah.
so it depends on how many vCPUs that you need if you're working with less.
Okay. You're absolutely right, and we'll cover that now.
Okay.
So, sorry, next slide. This slide. No, oh, I'm going back, not forward. That's why. Okay. So that was the knowledge worker piece, right? The VPC market, or a software edition that is targeted for the VPC market. In designer workloads, right, when you're trying to virtualize a high-end user, a CAD user, something like that, everything is a little bit different, right? And as Roy just mentioned, right, 2.3 gigahertz might not be sufficient for what they're doing, right? They typically have a workstation. This workstation has 3.5 gigahertz or more, right? Because a lot of these applications are still single-threaded applications, and they can benefit much more from high frequency than they can from multiple cores. So in the designer workspace, we actually test with servers that have much higher frequency and a little bit less of cores. But before I go into the benchmarking numbers that we have there, Jared kind of already mentioned that with Grid 5.0 we introduced a couple of new things. One is the new scheduling options. Anybody played with Grid 5.0 except today in the lab? 1, 2? Okay, not many. Okay, so if you're moving to Grid 5.0, right, and you're testing Grid 5.0, there are 3 scheduling options now. Scheduling options as into how do you share the time on the GPU, right? So what is your emphasis on? And I will summarize it. Is your emphasis on performance? Is your emphasis on quality of service? And based on quality of service, there are two different schedules. I cover them. So the best effort scheduler is basically the scheduler that we have had since the beginning of GridCast. So the beginning of 2013. So exactly like we used to have it. 10 minutes? Okay, that's good. We'll make it work. So what the best effort scheduler does is, right, again, we never share CUDA cores. We share based on time. So if you're allowed to work, you get all CUDA cores across all schedulers. We don't divide the GPU, we just divide time on the GPU. The best scheduler works as in, if you have 3 VMs running and all 3 are working, they are going to get round about a third of the time on the GPU. We don't have a perfect way of making sure that everybody gets 33%, but if 2 of them are working and 1 is not working, they're basically getting 50% of the time. So it's a scheduler which is great if you want to maximize, right, your GPU performance, right, because you're able to leverage unused time on the GPU, right? Downside is you might not be sharing it absolutely equally, right? So they're, depending on what the people do, they might have influenced another person. You know what? This has not been a problem in the field the last 3 years. We expect enterprise customers to basically run this scheduler. It's not the default scheduler, but we believe it's still the best scheduler for an enterprise customer. The new default scheduler is what we call the EcoShare scheduler, and once you install Grid 5.0, that's what it's installed with. The EcoShare scheduler basically makes sure, depending on how many VMs are active or are powered on, the time on the GPU will be shared equally. So 3 VMs, everybody gets a third of the time if you're using it or if you're not using it. So if you have 3 VMs running, 2 of them are actually working, 1 isn't, the 2 VMs are still only getting 33% of the time on the GPU, and you're basically leaving cycles on the table. But it's great in terms of quality of service, very predictable, right? So I don't know if you've heard any other company claiming more consistent performance. That's what they're doing. We have the option now. So you can choose what you want to do. If a VM turns off, right, both of the VMs will get 50% on the GPU. Next scheduler is the fixed share scheduler. This is a scheduler which is mainly implemented for CSPs, cloud service providers. They do it dependent on, not on how many VMs are powered on, but dependent on the VGPU profile that you assign to it. So if you have a GPU, let's say the P40 as an example, it has 24 gigs of frame buffer, and you assign all VMs let's say a 6 gigabyte frame buffer, you can run up to 4 VMs on that GPU. So it's giving you 25% of the time on the GPU, no matter if you're the only powered on GPU or if all 4 of them are powered on. Cloud service provider requires it because he wants to actually charge you, right, for these other cycles, right? He wants to make sure that's the amount of performance you get. If you want more, pay more, right? So that's...
Is that the same for AWS workspaces and the graphics side of things?
So AWS only uses GPU pass-through. They don't have vGPU, so this doesn't apply to them. Yeah.
Where do you change that scheduler?
It's a setting on the host itself. So you do it through the through the shell.
Oh.
So and it's a one-time
Not in the
thing.
GUI of...
Not now, but just how things have evolved over time, right? If something was only on the shell, it later, right, became visible in Zen Center or in vCenter. I'm sure we will see exactly the same there. Okay, so again here, right, if a VM turns off, nothing changes, right? That's the beauty of fixed share. So again, just putting that together, best effort. So the first one, the legacy one, right? Supported hardware, Maxwell and Pascal. We believe that's going to be the most common scheduler, even though EcoShare is the default scheduler. The importance here is this is really if you're looking for the best performance, right? Basically getting the most efficiency out of your GPU. It doesn't have guaranteed quality of service, but experience has shown it hasn't been a problem. And you need a frame rate limiter to be installed. The other ones focus on quality of service, and you don't need a frame rate limiter. Okay? Okay, performance now for the designer workspace. We have we are positioning the P40 as the follow-up to an M60 card. This is spec ViewPerf, so it's kind of the standard benchmark that is used in the designer workspace. That is what local workstations are being benchmarked with. And we're comparing here the best, like a 1 VM on the GPU, and you can see that the P40 is, right, sometimes up to 2x the performance, right, of the M60, but for other workloads it's not. Right? It's dependent on your workload. This just shows that the GPU actually has the performance, right? The raw performance of the P40 is double the raw performance of an M60, but dependent on workload, right? You might be able to leverage it, and sometimes you're not able to leverage. Once we do it at scale, you can see that, right, because one VM can't use it, but a second one will, right? You see that these numbers are getting higher on the P40 as an example, right? So if I'm just going to do this for a couple times, you see how, right, how the numbers, or how the bars on the P40 go higher. So the full potential of a GPU you will only see at scale. That's what I'm trying to say. With Grid 5.0, we do support the whole Pascal lineup. So there are other GPUs that you can also use. P4, P6 for the blades, P100 if you're looking for very high performance. P4, I'm just going to put it out there. P4 is a single slot, half width. It's actually as big as Emily's phone, right? And it is powered only through the PCIe bus. It's pretty performant, and we're seeing also interest in the field that people are using P4s as a follow-up to the M60, so a very viable option as well. Any questions? Comments? If I don't get a question, I'm going to be sad, because that typically means I did a bad job.
Can you just go
Thomas,
one slide back and then to this, because I actually... I don't understand that.
Performance?
Why it squeeze up?
P40?
So,
Oh, sorry, the other one was also the P40, right?
yes. I'll explain
What is
later.
the-
It's
the
just
first one
as
is
scale,
VMs.
you're exposing, so these are the aggregated scores of individual VMs. It just shows that with multiple VMs you can squeeze out more performance, and it's a more
Okay.
easier comparison. So again, you should buy the P40 instead of the M60, which is still available. You should buy the P40, or your customers should buy the P40 if you're looking for the peak performance that an M60 can't provide you, right? If you need more frame buffer than the M60 can provide you, an M60 board has two GPUs with 8 gigabytes each, so a VM can at most have 8 gigabyte of frame buffer. P40 is one GPU with 24, so you can give a VM up to 24 gigs. So again, P40 makes sense if you require more frame buffer per user. If you want to do compute, right, OpenCL CUDA, right, we are seeing interest in from customers now that they want to use their GPUs during daytime for VDI or DSH type things, and at night are interested in doing compute, AI, etc. Right, Pascal now allows us to do that. Compute is now enabled on all VGPU profiles, and if you're interested in the new quality of service scheduling options, P40 makes a lot of sense as well. Plus, the P40 has these weird VGPU profiles of 3 gigabytes, 6 gigabytes, etc., which an M60 doesn't have. That's when you would use a P40.
That makes the use more granular.
Correct.
That's perfect.
Yeah, exactly. Okay. That's it. Thank you very much.